Yeah, okay. Hopefully everyone can hear me now. So thanks to everyone for joining the second meeting of the ONNX roadmap discussions. We have the last meeting last week, and the recording of that has been posted. We're also recording this so that we can have it available for future referencing. So today, Harry helped put together a couple of topics that we want to cover, primarily around op definition, shape inference, and the IR itself. In the roadmap documents, we had a number of comments from several people about these topics. So these are the ones we wanted to kind of dive into in the half hour today. So the first one is around shape inference. And so I want to start the conversation with shape inference before moving on to the other ones. So there were a couple of suggestions around reorganizing the shape inference code, making it just more manageable, updating the model checker, and so on. And so I wanted to see if Chengming or Bushan are online to speak more about their proposals. I see Bushan is here. Bushan, can you hear us?
Hey, hi, yes.
Hey, how's it going? So thanks for providing these feedback and these comments in the roadmap document. Do you want to say a little bit about what you're proposing here?
Basically in the past I had lots of issues with shape inference. So I was referring to making or building a generic shape inference infrastructure, where we basically, whenever let's say something changes in IR, then we basically recompute the shape and we make it up to date with all the new information. So it was very generic towards the shape inference. And I think I had few more feedback in the doc, but it was more of, let's say, optimizations. But yeah, but the main feedback was more concerning about the shape inference infrastructure.
Oh.
So question. I just wanted to understand what what you described sounded like more to do with how to modify the model. Is that right? Because when you say you're talking about making changes to a model, right?
That's one aspect of it. For example, let's say in a hypothetical case that we have a model, but right now, let's say it's a sample of, and we don't know the shape, but we do copy propagation, and now we have some information available. And now with this new information, what we can do is we can, let's say we know the scale now. For example, a very big base case where earlier in PyTorch, script, to ONNX, it used to add more ops for upsample. Like for scaling, it used to add multiplication, division, and then it used to add upsample. So when we do, let's say, optimization, we remove those particular ops. At that point, we know this value of the scale. And now with this new information, we can basically recompute the scale, and we can pass this information ahead and basically recompute all the shape logic after that particular op. So I was referring more in that region, that how we can basically how we should ensure that shape inference optimization just go hand in hand, and basically we improve optimization as well as shape inference together.
I see.
Yeah.
So this has to do more with how best we can write optimizations so that they can also aid in shape inference after the optimization, right?
Correct. Yeah.
But for the current shape inference, it's difficult to it's difficult to achieve that because you don't know what optimizations can be applied.
Okay.
So like how I'm seeing this is more of this applies more to optimizations than to directly to shape inference. Am I right?
Yeah, but I mean, mm, correct me if I'm wrong. So we have optimization passes, right? And we have shape inference as a like separate entity. But what here I was referring to making a generic improvements in shape inference, but I'm also pointing to that, okay, maybe this can also be connected to optimizations to improve both together. But I agree that if it is segregated, if you keep it segregated, then this becomes like two independent issues.
So the way it works right now, I mean, I think I'm guessing this applies to ops where, say, the output shape depends on the input values of some operands, and because the input operand is a constant, we know the value, and then we are able to infer the output shapes. So the existing infrastructure already supports this, because the way the operator's shape inference works, it checks if the operand's value is known, and if it is known, it uses the known value to do the inference.
Right.
So the way, so it also depends on how the caller calls the shape inference method. And but to the extent, if you do constant propagation and are able to replace some subgraph by a constant and then call shape inference, it should be possible to already achieve this.
Right.
So
yeah, I agree here. Yeah.
All right. So looks like there are some probably low-hanging fruit around, updating model checker and things like that can be done. And then there's some other things that might require more discussion. Bhushan, Ashwini, Rama, are the capabilities that are being kind of requested here, I guess, do you feel like they belong in ONNX, or is it like some other place?
So,
like if it's optimization, it's not necessarily in core ONNX, right?
Right. Yeah. So it was not clear to me what exact changes we would do to shape inference.
Okay.
right, as Rama put it earlier, like so even today, what is being requested does exist in the sense that once you run optimizations, if the unknowns which are now known after optimizations, then you can always run shape inference again and use that to propagate the shape. So say after optimizations, if scale is now known for upsample, then just running shape inference again should work.
But that information sounds like is not available.
So what does it mean to rerun shape inference? Why a second run needed?
After optimizations.
Okay.
I think what I have proposed is already there. It's just that we need to call both in consecutive loops to achieve that. But the infrastructure is already in place.
Yeah. So I think this is also related to the point Prashant was making, in the sense the way the code is structured. We have the shape inference methods for each operator in place, but a different runtime could choose to invoke the shape inference for nodes at a suitable point in time. So in principle, I mean, it is already possible for a runtime to do optimizations and compute known values and then call the existing shape inference method where it exploits the information. But as Prashant said, the way code is structured now, the optimizations belong to a different framework, but that framework can call the shape inference to make use of the information that the framework has computed via optimization.
All right, so I want to make sure we cover some of the other topics as well. So for this one, I guess if there's more discussion to be had, I think the Slack channel for the architecture infrastructure group or the discussions board on GitHub would be great places to flesh out some more of these details about what is needed. And then we can take it into account for roadmap work items. So for the operator definitions, we had a number of folks suggesting to reduce the number of primitive operators since other operators can be composable with kind of lower level operators. And also a couple of comments about reference implementation. So I don't think Wei-Sheng is on, but Rama is here. So do you want to speak a little bit about this?
Yes. So yeah. So I guess with regards to reference implementation, so I think at some point we started adding reference implementations, but when we started adding new ops, but that exists in the form of a Python implementation in the test case generator, but it is not organized in a form where you could, for example, evaluate a sequence of ops. So I think, it is possible to extend this infrastructure to have the ability to evaluate, so for example, a sequence of ops using the reference implementation. And so one place where this would help potentially, for example, would be to improve testing for function definitions, because the way right now, when we generate test cases for ops which are defined to be functions, for example, we'll be able to do a sanity check to see if the function definition is consistent with the reference implementation.
Do you envision the reference implementation to be in C or Python or?
Python. I think the existing ones are all in Python.
Yes.
So.
Okay.
Yeah.
And currently it's not is it a requirement for checking in a new operator? I don't remember where it ended up.
It is, but I think it is a requirement. It is a requirement right now to add a reference implementation for the op. But the point I was making was that it is not organized in a fashion, so where you can conveniently call these different ops reference implementation in order to evaluate a sequence of ops. For example, if you want to evaluate a subgraph or the infrastructure doesn't exist. It's what exists there is sort of for a human being they can take a look and understand what it means, but we cannot conveniently call it from other testing code, for example.
So Rama, you mentioned that. So yeah, I do agree that we've already said, we've already made it mandatory to check in reference implementation for new ops. But to the point that you're making, to be able to run subgraphs, right? And especially for validating function definitions. I was actually thinking of adding some runtime like ONNX runtime to the CIs to do just this, because usually we construct functions from primitive operators which are pre-existing, which means that any runtime which claims, for example, ONNX runtime does claim that it supports all operators. So it does have implementation for those primitive ops. So we should be able to verify, we can verify the function subgraph using ONNX runtime, and we use that for the validation instead of going this route where you not only add reference implementation for individual operators, but also make it possible to run entire subgraphs.
And like adding to this, for example, when let's say reference implementation is not runnable, then basically it's very easy for it to get outdated. For example, if something changes, and it's possible that runtime implementation might diverge with what author is expecting it to work on. So it's also like easy to basically maintain it as a, let's say, unit test, and we ensure that runtime is not diverging with whatever is the reference implementation. And let's say tomorrow the runtime changes and some factor changes for the runtime, then we have that standalone reference implementation always to basically validate the parity. And I also look at the reference implementation as some sort of interpreter mode, where we just check one of interpretability and validation basically.
So just to respond to Ashwini's earlier comment, yeah, I mean, if there is a reference implementation based on ORT, of course, that's also an alternative. I mean, that is.
Yeah, in this case, I was just like what I was mentioning was directly using ONNX runtime in the CIs for validating the function. So when we write a function, we create two test cases, right? One with the expanded function body and one with the actual function itself as the node. So we can use ORT to validate the function body itself. Because this is based on the assumption that the function is composed of primitive ops which exist in ONNX. But we can't use ONNX runtime for new operators. If you were to have a subgraph which includes new primitive ops which are added in the new release, then we can't expect any other runtime to have that implementation, because ONNX, all the runtimes follow ONNX, right?
Yes, yeah, that is.
Yeah.
Yeah, I also second the idea to have some kind of runtime as reference implementation rather than just a very basic Python.
But how do we validate, let's say, if something changes in the runtime?
So this chicken and egg thing, right? You define the spec, someone has to implement it and make sense of the logic.
So I think so the first point is that we do need reference we do need a reference implementation for every op. We've already made it mandatory that when you're checking in a new operator, it needs to be the reference implementation for that should be included, and that reference implementation in Python. And how we do it today is we add it with the test case itself. So we definitely need that. There is no, there is like, I don't think this is for debate. What we are discussing is, should we have a way of also running a complete subgraph using this reference implementation?
No.
And this requires a lot of other work. And for this particular, and Rama mentioned the use case of being able to verify function bodies. To that, I was saying, instead of creating something different in ONNX, we can just use ONNX runtime based on the assumption that all the ops inside the function body will be the pre-existing primitive ops.
Sorry, so, I would like to chime in a little bit actually on this kind of thing. We are making ONNX very complex. So we do not need any kind of reference implementation. Indeed, we do not need that. What we need is, what we're talking about here is ONNX compliance, right? When we define an operator, we want to then. when we define an ONNX operator, we want to let people know what does it mean that if he or she wants to implement this op, then his or her logic is correct. We have test cases there, we have test data there, so we do not really care that much about how those test data is generated actually, right?
No, actually we do care. Because like
who will judge the logic, right? How you can you can I mean honest. So I technically I understand that when you guys say you care, I understand that, but step back a little bit, right? ONNX is a spec. A spec means that I have a description on all the operators. In the description, I'll also let you know the algorithm. I mean, how the logic of this operator, right? Basically, is a English, right? Is just a piece of English text, right? So the English text actually is equal to the codes somehow. So this is just a
ideal.
It's just in this spec we do not want to implement this spec. We don't want to.
Wait, no, the reference implementation serves to first remove the ambiguity in the English text, right? So it's not.
I mean, we can advocate it. So in our current test cases, right? In our current test cases, we are now advocating people to say, okay, can you write a piece of code actually instead of just listing data there to say, okay, this is input and that is output. This is the test data. Can you also write a piece of logic to say to be able to randomly generate some test cases there, right? We're advocating people there, but I personally don't suggest that's a must. No, that's not a must.
I actually support Ka here. I don't think ONNX as a spec needs to require a reference implementation. I think like if you look at the standard APIs in general, like it comes with a conformance test in the spec, but it doesn't come with a reference implementation.
I don't know if you all understand or interpret this the same way, but when you write a spec, you have 10 or 15 different ways to run an operator. So how can you tell exactly how these 10 different variations are supposed to work?
So I think that's the case for more rigorous compliance tests, not reference design, right?
That should be part of the again, how we interpret reference implementation as, right?
And what do you mean by rigorous compliance tests?
Right.
So if you're worried about missing corner cases in our spec, we're trying. I think rather than trying to solve this problem with the reference design, shouldn't we make the spec more clear and make sure that the compliance test that goes with the spec actually tests all these corner cases that we're worried about?
I agree. The reference implementation actually is there, and people is trying to ask that is because our spec is not clear. So I mean, the spec. Remember, ONNX is a standard. Is a spec. It's a very cheap thing. It's not a heavy engineering stuff. So the spec should be clear enough. So for example, if you are defining operators, and you have to let people know, even you have to use a piece of English text. Either maybe you can even just copy paste your code there as an English text, but we really don't want you to put this thing as a real program to say this is a reference implementation.
So I think here, I think reference implementation sounds like a very heavy term, and that may be the reason why you think like we are complicating this. But actually, like we've seen examples where that English description or definition that we are talking about has not been enough. In the ideal world, yes, what you are suggesting should be enough. But
so that's why,
unfortunately,
so that is why we are having test data, right? We are having test cases. That is why we are having very big compliance test case set, right? So if you are challenging to say, okay, the test case is also not good enough, then we should improve that.
So sorry, maybe there are two things. Let me try to distinguish them. One is something we already have as a requirement, which is some implementation for the op. I assume there is no suggestion that we should remove that requirement, that we are going to continue to have that requirement, right? So, but there is the other thing which I was suggesting, which extending it to, well, there are, as noted in the comment up there, I guess there's incompleteness in terms of earlier operators, I guess. And then I mentioned the need for testing. So that is an extension there. I understand, I can buy the argument that if you're saying extra implementation effort is not worth it, that's, I guess I understand that. But I mean, for the individual ops themselves, you need something formal, which is what we already have as a requirement, right? And that seems to make sense to me.
Yeah. I think we should, in my opinion, we should keep that
requirement. Sorry, I don't understand why we are why we are discussing about this. Are people thinking that the test data is not good enough, or or specifically which operator spec is not clear enough? We should actually collect those kind of information instead of debating this. I would suggest. So if you guys are suggesting to say have a reference implementation, then the next question is, will ONNX actually build a runtime like ONNX runtime? No, we will never do that. And people will keep pushing this kind of in this kind of direction. Yeah.
So see that. We're not suggesting that we build a runtime, a reference runtime in ONNX. What I'm saying is the original requirement, which already exists, that we have some reference implementation for the op which is being checked in.
That is because that is not really for reference implementation. That is for generating test data.
Yes, right? But I mean, if a function takes input for your operator and generates the output, then you have to write the code to implement that operator, right? And we're calling it reference because there is no sense of perf optimization or anything expected from it. It's just simple line of code, but instead of adding it to the description, make it a function.
Let me make myself very clear. I am not against. Actually, I'm also advocating that I'm not against people writing some Python codes to generate the test data in the when they propose an operator or they propose an operator update. I'm not against that, but I am definitely against to say having reference implementation is a must when proposing an operator spec. I'm definitely against that. You don't have to. Okay. But let's say if I can, so when I'm proposing an operator spec, I can when go to the test data part, I can write a Python function with the random input and then generate the output. Then I say this is the test data. I can do that. I can also do. I just give you a fixed data set to say, okay, this is a fixed list of inputs and the corresponding fixed set of outputs. I can also do that. Both works for me.
No, the problem with the second case that you mentioned is it's just not enough for someone who's implementing this operator in a runtime to properly test their implementation, because what we've seen is there are 1 or 2 test cases
Right.
Or even if there are 5 or 7 test cases, there are operators like resize and all and others also, which are so complicated. They have so many different attributes which change the outputs that
Exactly.
they are not enough for you to test your implementation. Instead, if you have a method like a function which implements this, then someone who's implementing this in the runtime has the ability to properly test what they're writing. I've also came across this issue where I've just seen already generated data for the test, and it has just not been enough, and it's difficult to find the author of this operator and go ask questions, right? So having some simple code available just solves this problem for everybody.
Yeah. You asked which operator. I would say start with resize and see how many test cases, how many variations we can write with the current code. Okay.
Yeah, and I implemented resize in ONNX runtime, so I can tell you. And resize fortunately had Python implementation, but without it, it would have been enough.
So actually, one of the reasons I don't like reference design is if you have a spec and well-defined test cases that covers all the corner cases that we care about, and there may be a corner case which is not covered by these test cases, that runtime may decide to, it's basically undefined behavior at that point, right? And runtime should have a freedom to do whatever they want if it's an undefined behavior cases.
But that's not difficult for different backend converters to decide whether they're doing the right thing or not.
Yeah, but spec should be complete. If it's not defined as spec, and if there's a case that runtime runs into, the runtime has freedom to decide whatever it wants to do, right?
It doesn't go the same way as you standard body, right? You define the spec, you should have same results no matter which runtime is implemented.
Yeah, same result within the defined spec. The spec should be complete. Spec should define
even
all the behavior
the results,
on the corner cases
how do
that
we
care
know
about.
The expected results is based on different attributes? If there's reference implementation for that.
Yeah, but I think we should just do a better job of defining all these cases as a spec.
Hey folks, this is a really great discussion, but we are over time. So if folks are okay with going on for a few more minutes, I think we can, but probably in about 10 minutes, we're gonna wanna wrap this up. And then we'll probably wanna continue offline. So go ahead and we'll continue for a few more minutes.
Okay, so I just want to add one more step here. It's kind of like the reason that you want to add a reference implementation here is that you think that these test cases are not good enough, coverage is not enough. So think about it. If we are saying that we want people to have some test cases there, how do they generate those test cases, right? Suppose that they do have some logic offline. I believe they do have some logic offline. The only thing I don't want to add the workload and also the burden here is to I mean, kind of like convert their offline codes, maybe in C, or maybe in C++, maybe in Go, and then to this kind of Python thing. That's the first thing. And the second thing is, again, this kind of ONNX thing, repo, I was thinking actually to move it to a really less engineering thing. I mean, as less code as possible. So we are now actually, if adding this kind of burden to people who propose the operator, this is actually moving in the other totally opposite direction. Yeah.
I just wanted to clarify, like I said that requirement for adding ops already exists. So I added a link to the chat. So if you think that's not a good idea, we should actually go and change, because the existing requirement says when you add a new op, we should provide a reference implementation in Python. But I mean, but I agree that I think most of us agree in the high level goal that the spec has to be complete, unambiguous in whatever ways we can make. I think that's clear, but yeah.
And to add to what Rama just said, like, yes, the spec should be complete, and we all agree on this point. Now, the next question is, how do we enforce it, right? Because yes, over here we all agree, but the reality is the spec there are issues, and that's why we decided, like, that's why we came to a conclusion that we want some reference implementation, right? So I see this a simple implementation to generate test data being a way of enforcing this, so that it's easier for people who are implementing these operators in the runtimes to make sure that they have they can verify all the cases.
So I challenge the simple implementation. I challenge this kind of simple. It's not that simple. It's not. To the spec, it's not simple. To the people, is also not simple. It's not.
No, by simple I meant there is no expectation of it of reaching some sort of performance. There's no performance goal or anything. There is no optimized implementation that is expected.
I would say the expected behavior is the most important one. Because if you want, you can also look at a loop operator. I think for version 11, there's no real test case. Now 2, but loop has 5 different scenarios, right? Anyway, the point is that we should have a bit more clarity as far as how the spec can be used.
I mentioned it, right? So I mentioned that, right? To say I'm okay. So even if you want to put this piece of code as in the description, I mean, as text, I'm even okay. There's people say, okay, I don't know how to write the English well to clarify the logic. I just want to copy and paste my code. Even this, I'm even okay. I just don't want to say this kind of a piece of code, running code, has to be a must in when proposing an operator.
So under the current rule, is there anything that prevents well, one of you from just using ONNX runtime to generate test data?
Yes. So usually ops go in first in ONNX, and then a runtime implements it. So an implementation in ORT is not always available. It's only available if we have.
That's a wrong thing. There's something wrong. Sorry, actually, there's something wrong. People even have no idea about what the fixed logic of this operator, how this kind of thing can be proposed. So this spec thing is idea. So I mean, by design, it is something coming after the industry engineering framework and also industry runtime is actually something after that. Unfortunately, that's the fact. So that means actually people, when people have some practice and also see that, okay, this is a real common thing and this is widely used in our models, okay, I'm going to propose it. We should never say something like, okay, now I have some idea in my mind and I want to propose an op in ONNX, and then, okay, following the spec, I'm going to implement the logic in my runtime. In my mind, that's the wrong way, actually. So in that way, ONNX is a playground, right? It is not.
No. So one of the requirements for adding a new op is also that it should be implemented in a well-known framework. What I meant is it cannot always be. It may not always be ONNX runtime.
regardless of where this kind of operator proposal from, where it is from, wherever it's from, I believe this is what I'm going to trust. I believe the one who proposed the operator, he or she has already have a very, very good implementation in his runtime or his framework. And actually he or she also has a very good usage of that. And it proves to people and that operator is useful. And then he or she goes to ONNX to say, now I'm going to propose it to the spec. That should be the logic.
Yeah, most of these are already requirements for adding a new operator.
Yeah.
Or rather, I would say all of this, except that there's one more requirement, that there also be a reference implementation in Python. Now, this is already approved, and I think we can use the operator SIG meeting to like go over this again, because right now I don't think Mikal or Imad are here, so we should use the operator SIG meeting to have further discussion if people don't mind. Because this is something which already exists.
Right. If the proposal is to change the policy for adding a new op, then the operator SIG is the right place to do it. So I want to wrap up the meeting for today, since we're actually already 15 minutes over. Thank you for the discussions and thank you for the inputs. I think this is a really interesting and important topic to resolve. I would suggest that in addition to the SIG conversation, you can also start a discussion on the GitHub discussions board, so that we can get more community members' thoughts on this. I think this really boils down to, you know, what is are we talking about reference implementations or compliance tests? You know, kind of get to the root issue here, rather than about kind of the structure of the reference implementation. Can we run subgraphs on it? I think we can get down to the lower, more fundamental question that we probably need to answer first. So anyway, I want to say thanks to everyone, and in the interest of time, we'll wrap up here, and we'll see everyone next week. Next week, the meeting is on Thursday, and we'll see you all then to continue discussions on the roadmap. Thanks. Bye.
Thank you.
Thanks, everyone.
Okay.
Bye for now.
Bye.
Bye-bye.
Thank you. Bye-bye.